Okay, our goal is to find the period of sinusoidal functions. So we're talking about sine and cosine. Basically, if you have a number out in front, that's going to affect the amplitude of each one of these graphs, but it's not going to affect the period. The period is how far it takes before it starts repeating itself. What you're looking for in those cases are you're looking for a multiple attached directly to x. So where this b is sitting for sine or this b is sitting for cosine. Illustrated down below here, we have in blue is the regular sine of 1x graph. And you can see that it starts at 0 and it ends at 2 pi. Its normal period for sine and for cosine is 2 pi. Um, then if we take a look at some different graphs here in red, you can see we have sine of 2x. So it goes up, starts at 0, comes back down, and then finishes before it starts repeating itself at pi. So this actually gets 2 periods in the exact same allotment as the original graph did between 0 and 2 pi. So that means that this red graph has a period of simply pi. All right, the green graph, sine of pi over 2 or sine of 1 half, um, sorry, that's sine of x over 2 or sine of 1 half x. That's going to take twice as long until it starts repeating itself. So we've only drawn half of that first period of sine of x over 2. So let's do a few of these computations. They're really not that difficult and figure out what's the period of sine of pi over 6 multiplied by x and then cosine of x over 3. So whenever you're doing this computation for the period, it's always the original period. So 2 pi for sine and cosine situations here. 2 pi, their original period, divided by this multiple on the inside. And technically, it's the absolute value of the multiple on the inside. So as we get setting this up, I'm going to write 2 pi divided by the absolute value of pi over 6. So the absolute value of pi over 6 is just pi over 6. And then we want to do a little bit of simplifying down here. So in this case, I'm going to go ahead and multiply numerator and denominator each by 6 because I don't like having a fraction inside of a fraction. My goal here is to eliminate this fraction from the denominator basically. So multiplying by 6 will counteract this dividing by 6. And really when we multiply and divide by the same thing, that's going to make a 1. So for our numerator, we're going to have 2 pi multiplied by 6 is going to make 12 pi. And then our denominator, we're still going to have a pi down in that denominator for the time being. With a little bit more simplifying down, hopefully we recognize that we have pi in the numerator and pi in the denominator. So those will get to simplify down and make a 1. So what's left is we still have 12. So the period for sine of pi over 6 times x on the inside here is going to be 12, meaning that it'll start at 0 and finish 12 units later on the x-axis. All right, one more quick example here. We have cosine of x over 3. So it may be worth noting in this case that this means cosine of 1/3 multiplied by x. So if we think about it like that, we have a multiple on the inside here of 1/3. So that's going to be our value for b that's going to get filled in here. Again, as we make this computation, I'm going to go ahead and say 2 pi, the original period of cosine, divided by the absolute value of 1/3 is just going to be the same thing as 1/3. So I'm just going to write 1/3 down here in the denominator. Okay, a little bit of simplifying down. We don't want to leave this as fractions inside of fractions. So I'm going to multiply both numerator by 3 and denominator by 3. By multiplying by 3 over 3, that's like multiplying by 1. So it's not going to change the overall value here. It's just going to make it look different. All right, so I multiplied by 3 because 3 times 1/3 makes a 1 in our denominator. But our numerators, as we multiply those together, we have 2 pi times 3 is going to be 6 pi. And then our denominator here we said was going to equal 1. So ultimately we get 6 pi divided by 1 is the same thing as 6 pi. So I hope this helps out as we try to compute the period for each one of these. Just remember it's always the original period for either sine or cosine divided by that multiple on the inside. From there, if you set it up correctly, it's just a little matter of doing some algebra and simplifying down. Hope this helps out. Good luck.